Hello everyone, welcome to the Macri Virtual. Hope you are doing good. Today I'm going to continue with your chapter number 10, that is system level input output. In the last class we have started with this topic, that is chapter number 10, system level input output. This is a topic, very easy topic, interesting topic, means what are the inputs and what are the outputs that is given to the system, that is given to the Unix operating system or any operating system, that is a system level input output. That is at the system level, what is the input and what is the output for producing the result. That is a system level input output. So let's take a quick review what we have covered in the last class and then continue with the next topic, that is today's topic. We have started the 10th chapter in the last class, that is the system level input output. In this we have studied multiple topics, that is what is the content of what are the contents of this chapter, that is Unix input output, opening, closing, reading, writing, robust, file metadata, sharing, input output redirection, and so on. So we have studied about the topics that is covered in this chapter. Then we have covered what is the input and what is the output. That is what is input, what do you mean by input? That is copying the data between the memory and the external devices, that is the input. Again, that is also the output, means copying the data from the memory or copying the data from the files to the memory and memory to the files is done by using the input and the output. So input means copying the data from the any device, that is input output device like keyboard, mouse, monitor, from to the memory, that is from file to the memory is known as the input, and from memory to the file or memory to the device is known as the output. It means whenever we store something in the memory, that is the input, and whenever we get something from the memory, that is the output. So there is a difference between the input and the output. And we have studied about the standard input output library, that is what is the standard methods or what are the standard method that is available for the input output, that is known as standard input output library. Why they are known as standard input output? The main concern is that they are these input output are common to the programming language. That is, if I am using the C language, that is common for me, and if you are using the C language and both of us are using the C language, then the same input is given, same output is taken. But yes, the standard output or input and output is dependent on the programming language. That is, it varies from programming language to programming language. Like in C, there is a different concept for input, like printf, and for output there is a different concept. That is, displaying the output is done by the printf, and the storing the data in the memory is done by the scanf. In the same way, the input and output is done in the C++ by using the cin and the cout. So in C there is a printf and the scanf, and in C++ there is cin and the cout. There is a difference, or we have studied that there is a difference according to the programming language. Then we have studied that what is the use of Unix input output. That is why we are studying that what is the input that is given to the Unix operating system and what is the output that is generated from Unix operating system. That is, what is the advantage or why we are using this one. The main concern is that understanding the Unix input output will help you understand other system concepts. That is, it helps to understand other system concepts. That is, what is going there, or what is the concept that is available for the input and the output. This says input output is integral to the operations of a system, and because of this we often encounter circular dependencies or dependencies between the input output and the ideas. For example, input output plays a key role in process creation and execution. That is, whenever we understand, or whenever we are going to understand the Unix input output, that helps us to understand the system concepts also. Sometimes we have no choice but to use the input output. That is the why we are using the Unix input output. That is there no other option. Now, then we have studied the first topic, that is Unix input output. That is, what is the Unix input output? That is a sequence of the M bytes. So any file, any Unix file is a sequence, is a multiple of or a sequence of the M bytes that is available for the programming. This is all the input output devices such as network, disk, terminals are modeled as a file. This means in Unix everything is treated as a file. Even the folder is also treated as a file. Even any network device is also as a or treated as a file. And all the input and output is performed by reading and writing the appropriate files. Then we have studied what are the methods or what are the tools that is available for the input and the output. That is how we can open the file and how we can close the file. Then we have also studied about the opening and the closing the file. That means first of all, if I want to get some data from the file, so first operation is to open the file. That concept is known as opening a file. We have studied that opening a file is done by using the open function, that is the OPEN. Then we have studied how to change the file position, that is from 0th position to the 3rd position, then reading and writing the files, then closing the file. So these are the 4 operations that we have studied in the last class in detail. First of all, that is opening the file. How to open? Using the open function. This is the open function converts a file name to a file descriptor and returns the descriptor number. What is a descriptor number? That is a file descriptor that shows that the file is of which type or file is of contains how many bytes. That is a file descriptor. And there are 3 methods for accessing the files, that is read only, writing only, and reading and writing. So if I'm using RD only, that means this file is only for read purpose. If I'm using WR only, that is used for writing purpose. And RDWR means reading as well as writing both. These are the multiple access permission bits that we also studied. That is IRUSR. That is user can read the file, in the same way user can write the file, in the same way user can execute the file. So there are basically 3 types of permission. One is read, one is write, one is execute. And the read permission is denoted by the R, write permission is denoted by the W, and the execute permission is denoted by the X. And depending on the user to user, depending on the person to person, these 3 permissions are executed. It means if there is a user, that is using the USR. If there is a group, that is GRP. In the same way, if there are others, that is except the user, except the group, there is another person that is using the file, that is other. Others can also read the file, write the file, as well as executes the file. This is the syntax that we have studied, how to open the file. Then we have studied how to read and write the file. One more thing that we have studied, finally a process closes a open file using the close function. That means open is done by using the open function, closing a file is done by using the close function. In the same way, we have also studied about how to read and write the file, that is reading and writing the files. First of all, open and close, then reading and writing. That is application perform input and output by calling the read and the write functions. This is the read function, this is the write function. The read function copies at most n bytes from the current file position to the memory location buffer. The write function copies at most n bytes from the memory buffer to the current file position. That is vice versa. Read means from file to the memory location. Write function means from the memory to the file position or the current file descriptor. Yeah, then we have also studied the new concept, that is the shortcuts. That is In such cases, or in some cases, read and write transfer fewer bytes than the application request. That is, read and write functions gives the less number of bytes than the application request. Such cases or such scenarios are known as the short counts. That is a short count that do not indicate an error. They occur for a number of reasons. Why they occur? Now, what is the main reason? First of all, encountering EOF on the reads. We have studied. Then what is the reason why there is a short count, and why there is an short count in the program, in the input and the output? Well, what is the main reason? First of all, the encountering the EOF, that is, encounting means there is a EOF, that is end of the file on the read. That is, EOF is occur on the read. For example, I am reading the file and suddenly the EOF can occur, or EOF occur. That is, EOF occur, so there is a short count. That is, number of the bytes that is distributed are the few than the application request. The next way, or the next reason why they occur, or the why short count occur, reading the text line from a terminal. That is, reading the text file from the terminal, that is using the device, either keyboard, display, monitor. Then reading and writing network socket. So these are the few reasons why there is a short count, why there is a shorter transfer of bytes than the application request. The next reason is that reading a text lines from a terminal. Then reading and writing network sockets. This is also the next main reason. That is why there is a read and the write operation, or why there is a short count of the bytes than the application request. In practice, you will never encounter short counts when you read from disk except file on EOF, and you will never encounter short counts that when you write to disk files. Next, this is the today's topic. So that is what we have covered in the last class. Now I'm going to start with a new topic, that is robust reading and writing with the RIO package. That is the limitation that we have studied. What is the limitation? There is a short counts, that is less number of bytes are transferred than the application request. That limitation is removed by using the new concept, that is robust input output, that is RIO package. That is robust reading and writing with the RIO package. This says in this section we will develop an IO package, that is input output package, known as the RIO, robust input output package, that handles these short counts for you automatically. So that is what I said, that these short counts are removed, or these short counts are removed automatically by using the RIO package, that is robust input output. There is no manual way, but these short counts are automatically removed or automatically deleted by using the RIO package. The RIO package provides convenient, robust and efficient input output in applications such as network program that are subject to the short count. The same line, this is one of the package that provides an efficient, robust input output operations in applications such as network program that are subject to the short count, that are having the short counts. RIO provides two different kinds of function. So this is the functionality of the RIO, that provides two kinds of different function. One is unbuffered input output, one is buffered input output. In unbuffered, these functions, that is unbuffered functions, transfer data directly between the memory and the file with no application level buffering. That is, there is no application level buffering. They transfer the data, or the data will be transferred directly between memory and the file. They are especially useful for reading and writing binary data to and from the network. That is, unbuffered is basically used for transferring or for reading and writing the data or binary data to and from the network. That is, from the network they are using, or whenever we want to access any file from the network, then we are using the unbuffered input and output functions. In the same way, next one is where buffered input function. One is unbuffered, that is used whenever we have to read and the write data from the or to and from the network. Next, buffered input function, that is these functions allows you to efficiently read the text lines and binary data from the file whose contents are cached is an application level purpose, similar to the one provided for the standard input output functions such as printf. The buffered functions allow you to efficiently reads the data from the binary file, from the binary data, from the binary lines which are cached in an application file. It just similar to the whenever we use the printf in the C language. Unlike the buffered input output, the buffered RIO input functions are thread safe and can be interleaved arbitrarily on the same descriptor. That is, if I am using the buffered input function, that is very similar to the printf. So RIO package contains two functions. One is unbuffered, one is buffered. And the unbuffered contains reading and writing from the terminal. And the buffer contains the reading the files from the data, or reading the files, the text lines and binary data from a file into an application buffer. We are presenting the RIO routine for two reasons. First, we will be using them in the network applications we develop in the next two chapters. Second, by studying the code for this routine, we will gain a deep understanding of Unix input output in general. Now, let's start with the first one, that is RIO, unbuffered input and output functions. So let's take a review of the PPT also. This says RIO is a set of wrappers that provides efficient and robust input-output in application such as network programs that are subject to the short counts. The same line, that is whenever there is a short count, then we are using the RIO package. This provides two types of or two different kinds of functions. One is unbuffered input and output. One is buffered input of binary data and the text line. This is unbuffered input and output of binary data. One is buffered input and input of binary data and the text lines. This is RIO read and RIO return. So in unbuffered, there is an input, there is an output. For input, this is used, that is RIO underscore read n. One is RIO write n. So one is used for reading and one is used for writing from the terminal. Then in buffer, there is a RIO read line. One is RIO read NB. One is line, one is NB. That is a text lines. One is used for binary data. Clean up some problems with Steven read line and read n functions. This says unlike the Steven routine, that is the earlier approach, these are the thread safe and can be interleaved on the same descriptor. Now let's start with the unbuffered RIO input and output. This has the same interface as Unix read and write. That is, this is the same as we are using, or as we are we have a data or we have a content for Unix read and write. Especially useful for transferring data on the network socket. As I told you with the help of the book, this unbuffered is generally or especially useful for transferring the data on the network sockets. Network sockets means on the network terminals. This is the example. One is SSIT RIO read n. So one is used for reading, one is used for writing. The same arguments are used. One is FD, one is using the pointer, that is USR user buffer, one is size TN. Again, next line is used for writing purpose, that is write an int. This is not empty, this is int fd void user buffer. One is size t n. Return, what is the return value? That is num dot byte transferred if okay 0 on end of the file. That is it returns a 0 whenever it reaches or the pointer reaches to the end of the file, and -1 on the error. So it gives the output as a 0 whenever there is a end of the file, and gives the output as a -1 whenever there is a error, and it gives the number of bytes if the code is the okay. That is, if the code is correct, it gives the number of bytes. This says RIO read and return short counts only if only it encounters EOF. Then write and never returns a short counts. Calling to the read and the write and can be interleaved arbitrarily on the same descriptor. This is the example for the read and this is the same example using the variables, using the buffer, using the function. Now let's see with the help of the book. The same example is over here. This says it transfer to n bytes from the current file position of descriptor to the memory location user buffer. This means this line transfers the n bytes from the file location from the file position of descriptor, that is fd, to the memory location user buffer. So transferring the file from the file descriptor to the user buffer. In the same way, RIO write-in transfers the byte from the location, that is a user buffer, to the file descriptor, that is a fd. Then read-in can only return a short count only if it returns the end of the file, and the write-in never returns a short count. This is the difference between the reading and the writing whenever we use the RIO. That is, read-in only encounter a short count whenever it encounter the EOF, but write-in never returns a short counts. Calls to the read-in and write-in can be interleaved on the same descriptor. Now next is your RIO buffered input function. So till now we have covered how to read the data and how to give the input and how to extract the output. Next is RIO buffered input function, that is how to take the input or how to fetch the input directly from the memory devices or from the binary file or for the binary lines as well as the text lines. This says a text line is a sequence of ASCII character. As I told you, what do you mean by ASCII? That is American Standard Code for Information Interchange. I'm repeating again, American Standard Code for Information Interchange. So if I'm saying a text line, that is a sequence of ASCII characters that is terminated by a new line characters. On Unix system, the new line character is the same as the ASCII line feed, that is a LF, and has a numeric value of 0x0A. Suppose we wanted to write a program that counts the number of text line in a text file. This is the example, that is I have to write a program for counting the number of text lines in a text file, that is the ASCII characters in a text file. One approach is to use the read function to transfer 1 byte at a time from the file to the memory. As I told you, checking each byte for the new line character. The disadvantage is that it is very inefficient, time consuming, requiring a trap to the kernel to reach or to read each byte in the file. So this is a limitation, that if I'm using that method or this method that transfer the file or byte from one location to the another one by one. So this consumes lots of time. Also we have to check the EOF, end of the file, new line character. So there are so many constraints that is available in this method. So there is a better approach, that is to call a wrapper function, that is a RIO read line B, that copies the text line from the internal read buffer, automatically making a read call to refill the buffer whenever it becomes empty. So it uses the wrapper function that is known as RIO read line B. That is the function that is used for reading the binary files, reading the text line, and also refill the buffer whenever it becomes the empty. For lines that contain both text lines and binary data, we will also provide a buffered version of RIO read and known as the RIO read NB that transfers the row bytes from the same read buffer to the as RIO read line B. So this is the example that is using read init B, then read line B, that read NB. So two functions are used. One is RIO read NB, one is RIO read line B. So one is line B, one is NB. This is the example that is using the CS application.header file, then SSI's RIO read line B, that is using the read line B, then RIOT RP pointer RP user buffer maximum length, then RP pointer RP user buffer size n. This says the RIO read line B function is called once per open descriptor. It associates the descriptor FD with the read buffer of type RIOT at address RB. That is, it reads the data by using the pointer, that is which pointer? That is a read buffer pointer of the type RIOT at the address RB. Then next point says the read line B, this is the line B, reads the next text line from the file RP. This is the next file, this is the first file, this is the next file, that is RP, including the new line characters, copies to the memory location user buffer, and then terminates the text line with the 0 character. This is the size that is using the maximum length. So first of all, it reads the data, copies the data, or copies the location or every file or every byte to the user buffer, and then terminate whenever there is or whenever reaches to the maximum length, that is a 0 character. In the same way, the line NB reads at most maximum length minus 1 byte, leaving the room for terminating null character. That is, it is using the maximum length as a -1. Why -1? Because it is it vacates the room for the null character that always placed at the end of the line. That is a null character. However, calls to these buffered functions should not be interleaved with call to the unbuffered RIO readn function. You will encounter numerous examples of RIO function in the remainder of this text. This is the example of the RIO readn. These are the various examples, that is the RIO readn and writen. In the same way, this copies the data, that is the copies the data from the standard input to the standard output. This is the buffer format, that is RIO buffer size or read buffer. Again the example, this is again the example for the RIOT and the RIO read init B. This is the example for the init RIO read function. This is again the same examples in C language, that is line B and the line NB. These are the examples of the RIO package. Now let's see with the help of PPTs. Then we have already studied what is the buffered RIO input function, that is efficiently read the text lines and the binary data from a file partially cached in the internal memory buffer. That is, it reads the text line as well as the binary data from the file that is using or that is partially cached in the internal memory buffer. This is the same example using the RP, transfer the byte by byte, that is 1 byte to the user buffer, next byte to the user buffer till the maximum length minus 1. This is the read NB. It also reads the data, transfers the data till n. That is the reading the data till the n value. This is used for the text line. This is used for the binary data. This is NB. It returns the number of bytes read if OK, 0 on EOF, -1 on error. That is, it gives the 0 on the EOF, -1 on the error, and gives the bytes read if OK. This is the explanation. The same explanation. RIO read line B reads a text file of up to maximum byte length from the file FD and stores the data. The same example. Then next point says especially useful for reading the text file from the network socket and so on. Then RIO read NB reads up to n bytes from a file. That is the same. Calling to the RIO line B and the RIO read NB can be interleaved arbitrarily on the same descriptor. Don't interleave with calls to the RIO read N. This is the warning. This is the example. The same example which we have studied, that is copying the line of a text file from a standard input to the standard output. That is how to copy the text lines, not the binary data. Text line from the standard input to the standard output. So remember, this is the case of the buffered input function that is done by using the read init B, the read line B. Why read line B? Because it is copying the data or copying the lines of the text file, not the binary data. If I am using the binary data, so it should be read NB. So there is a different function, there is a different concept, there is a different scenario. So this is the example. First of all, a header file is attached, that is csapp.h. Then there is a main function. There are two types of argument. One is argc, one is argv. Argc is of integer type, argv is of character type, and it is also a pointer. Then int n, riot, rio, so it is declaring the variable. In the same way, there is a buffer that is of array type, that contains the maximum line. Then use the init b, that is initializing the buffer, using the buffer or using the arguments as a RIO, stdin, file number, that is standard input, or by using the file number. Then using the while function, that is checking the condition, that is n equals to, means storing the value of read line and buffer maximum line is not equals to 0. That is, it gives the short counts whenever it encounters the end of the file. So that's why it is using the while function, that is if it is not equals to 0. Sorry. Not equals to 0 means it does not reaches to the end of the file. Why? Because if it reaches to the end of the file, there is a short count. So it counts until it is not equals to the 0. Then use the RIO write n, that is first of all use the read line n, then use the write n for writing the files by using the standard output. This is the standard input, standard output buffer n. So this is using the buffered function, this is using the unbuffered function. Then at last exit 0. Why? Because it is using the int main. So this is the example. Now next topic is your file metadata. This is the new topic, that is reading the file metadata. First of all, what is the metadata? That is data about the data, that is data within the data, that is known as the metadata. That is this says an application can retrieve information about a file. Suppose I am using one application. So if that application retrieves the information about the file, sometime known as the file's metadata, by using the or by calling the stat function and the fstat function. So whenever an application wants to retrieve the information from the file or about the file, that is what is the data structure, what is the data type that is used, that is done by using or by calling the function that contained in the file metadata, that is stat function and the fstat functions. So if in assignment or in exam there is a question that there is a file metadata, that is how to read by using the fstat function and the stat function. The same example, this is including the file, that is hash include unist.h, hash include sysstat.h. Why it is using sysstat? Because it is using the stat function, that's why it is using system/stat.h. Then using the two functions, that is stat and fstat. One is the stat, it is using the variables arguments, that is constant char file name struct stat buffer. So it is using two variable, one is the file name, one is the buffer. Then fstat, there is a file descriptor, there is a buffer, that is the memory. So in stat there is a file name, buffer. In the fstat there is a file descriptor and the buffer. Now what is the explanation? The stat function takes as input a file name and fills in the member of a stat structure shown in figure 8. That is, this file name is using for taking the input as a file name and fill the members of the stat as shown in figure 8. In the same way, fstat is very similar but takes a file descriptor instead of the file name. This is the figure 8, that is the stat function, how it is used, how it is using the buffer, that is struct stat. First of all, there is a device, there is a inode, that is standard sti node, that is the stat inode, mode t, that is the st mode, nlink, that is the number of hard links, user id, group id, device types, total size, that is the size, the block size for the unsigned integers, for the unsigned log integers. There is a time of the last access, there is a time of the last modification, this is the access time, modification time, this is the last change, that is the time of the last change. This is the metadata that is written by the stat and the fstat functions. This is the stat structure. This is the macro for determining the file type for the st mode bits, that is is register regular, not res, it is reg. Is it a regular file? If this is the directory file, if this is a network socket. So these are the three macros that is used. The st size member contains the file size in the bytes. The st mode member can counter both the permissions. This is using, that is RGB stat. If it is a regular file, type equals to regular. That is determining the regular file. One more concept. This says the st size member contains a file size in bytes. The member encounter both the file permissions and the file types. Unix recognizes three kinds of file, number of different files, that is regular file, one is directory file, one is socket file. And kernel makes no difference between the text file and the binary file. That is, regular file contains the binary or the text data, but the directory file contains information about other files. A socket is a file that is used to communicate with other process, with another process across a network, that is used for communication. So one is regular, one is directory, one is socket file. This is the code that is used for checking the file type using the struct variable, that is stat, using the char pointer type, that is a read okay, that is if it is okay then it is read okay. Then using the stat argv stat, if it is a regular file, that is determining the file type. If is regular, then type equals to regular. Else if is directory, then type equals to directory. Else type equals to other. Then using the mode, that is if it is regular, that is a user mode, then check the read access. If it is a user mode, then okay, else no. This is how to modify the st mode bits. Now let's see with the help of PPT. This says metadata is data about the data. As I told you, metadata is what? That is data, or that is maintained by the data. That is a data about the data, in this case the file data. Metadata is maintained by the kernel, accessed by the user with using the two functions, that is the stat and the fstat functions. This is the same. There is a device file, inode, number of hard links. So these are the metadata, that is a data about the data that is returned by the stat function and the fstat function. This is the protection file, number of hard links, user ID, group ID, device files. Next is, this is the example of accessing the file metadata, the same example which I told you with the help of book, that is a regular file, regular, directory, other, the same. Now the next concept, how the Unix kernel represent the open file, that is how it will be representing the open file. This says two descriptor referencing two distinct open file disk files. Descriptor 1 points to the terminal and the descriptor 4 points to open the disk file. That is stdout that points to the terminal and the descriptor points to open the disk file. This is the descriptor table, one table per process, open file table, vnode table. That is fd0, 1, 2, 3, 4. That is the open file, that is file A, file position, that is vnode table, file access, file size, file type. This is how it will be represented a open file. This is the open file table, vnode table and the descriptor table. Now next topic is your file sharing. This is the next topic. So till now we have covered RIO package, and the last topic, that is the stat function and the fstat function, that is the file metadata. Now the next topic is your sharing a file, that is how file will be shared among the different network, among different files, that is how they are communicated with each other, that is sharing a file. This says Unix files can be shared in a number of different ways, that is files of the Unix can be shared in a number of different ways. Unless you have a clear picture of how kernel represents open file, the idea of file sharing can be quite confusing. That is, until you do not have a idea about how to how kernel represents any open file, then it is very confusing if I am trying to understand you that how to share the file. So first of all it is very interesting, very careful that how to use the concept, that is how to open the file, how to represent the open file, that is done by the kernel, that contains three related data structure, or that is done in the three related data structure. One is the descriptor table, one is the file table, one is the vnode table. As I told you with the help of PPTs, the descriptor table has a separate descriptor table whose means every process or the each process has a separate descriptor table like this one. This is the separate descriptor table for each process, that is one table per process whose entities are indexed by the process open file descriptor. This is the process file descriptor. This is these entities. One is the file A, the file B, in the same way file C, file D. Each open descriptor entry points to an entry in the file table. That is, every open descriptor, that is an open descriptor, that is for example FD1, that is an open descriptor that points to an entry in the file table, that is a file A. In the same way, next is your file table. This is a set of open files. This is the set of open file like file A, file B, that is represented by a file table that is shared by all the processes. Each file table entry consists of the current file position, reference count that currently points to, and the pointer for the vnode table that consists of the position, reference count, as well as the link that is connected to the vnode table. Closing a descriptor decrement the reference count. The kernel will not delete the file table entry until its reference count is 0. Next, last one is your vnode table. So one is your descriptor table that is available for each and every process. One is your open table file or open file table that is shared by processes that contains multiple options like file position, reference count, vnode table. Like the file table, the vnode table is also shared by all the processes. Each entry contains most of the information in the stat structure, including the st mode and the st size. This is the file access, type, size. So this is the vnode table. So these are the three types of tables that kernel represents the open file by using these three related data structure. This is the same example, the same table, that is a typical kernel data structure for open files. Two descriptor reference distinct value. This is the example, that is two descriptors reference two distinct files. There is no sharing. That is FD1, FD4. Two descriptors are used. There are two files, file A, file B, that can use the different function. Means there is no sharing among these files. They are two distinct process. They are two distinct file tables. This is descriptor 1 and the 4. The same example, two files, two distinct open file table. This is the typical situations where the files are not shared, where each descriptor corresponds to a distinct file. Multiple descriptor can also reference the same file through different table entries. The same example. This might happen, for example, if you were to call the open function twice with the same file. That is, multiple descriptor reference the same file. That is, FD1 is representing the file A, also reference to the file B. Why it happened? Because the open function is used with the same file name. This is the example of the file sharing, FD1 file A, FD4 file B. But these two files are shared by all the processes. These two files share the same file access, same file size, same file type. So this is the example of file sharing. This example shows two descriptors sharing the same disk file. That is, this is the two descriptor sharing the same disk file through two open file table entries. This is file A, file B, but use only the same or the shared vnode table. Next, how a child process inherit the parent open file. Now, there is a concept of the parent table and the child table. One is the parent table, that is the base table or the main table that is using the all the entries or using all the data structure. One is the child table that inherit all the content of the parent table. That is, and this is the concept how a child process inherits the parent open file. That is how child can access, or how child is able to or going to understand, or how able to take all the contents that is available for the parent. That is how to inherit the contents of the parents. The initial situation is figure 11. That is the initial situations. One is parent table. There are 5 file descriptor. There is a child table. There is a 5 file descriptor. This FD1 and FD4. FD1 is linked with the file A. FD4 is linked with the file B. In the same way, for the child table, FD1 is linked to the file A and the FD4 is linked to the file B. Now, file A is shared, or file A is accessing the different vnode table, and the file is B is also accessing the different vnode table. That means there is no sharing, but this is the concept how parent table or the how child inherits the parent open tables. How it will inherit? By using the file descriptor. We can also understand how parent and child process share the file. Suppose that before a call to fork, the parent processes the open file shown in figure 11. The same example, this is the figure 11. This is the figure 11. This is the simple process that there is no sharing. And figure 12 shows sharing among the files, among the open file. And this is the example how the parent and the child share the same file. This is how this is sharing the same file. Parent is also having a file A, parent is also having a file B. Child is also having a file A, child is also having a file B. This says, then the figure 13 shows the situation before after the call to the fork. The child gets its own duplicate copy. This is the child gets own duplicate copy of the parent descriptor. Parent and the child share the same set of open file table. This is sharing the same file and thus share the same file position. An important consequence is that the parent and the child must both close their descriptors before the kernel will delete the corresponding file table entry. That is a more important restriction or constraint, that both the parent as well as the child both close their descriptor before the kernel will close or will delete the table entries. Now, this is the concept of the file sharing. That is how file sharing is done. First of all, there is no sharing. The first figure number 11. Then figure number 12 shows the sharing among the different processes. Then figure number 13 shows the file sharing among the parent process as well as the child process. Now, let's see with the help of PPTs. File sharing, this is two distinct descriptor sharing the same disk file to two distinct open file entries. Example, calling open twice with the same file name argument. This is the file sharing, the same example of figure 12, that is file A and file B sharing the same access file, the same access, the same file type. That is the file size is also the same, the file type is also the same, that is a regular directory file or the socket. In the same way, there is the same file access modes, that is a read mode, write modes, execute mode. In the same way, there is the same file type, file size, whether it may be of 59 bytes, 54 bytes, 53 bytes. Then how processes shares the file. The same example, a child process inherits its parents' open files. Hence, it is the situations immediately after false. Here, it is a condition situation that is immediately after a fork. Now, next is your input-output redirection. This is the topic. This says Unix shell provides input-output redirection operators. That is, what are the redirection operators, or what are the input-output redirection operators? So Unix provides multiple input-output redirection operators that allows users to associate standard input and output with the disk file. That is, it has a facility that is available or that is provided by the Unix to use the input-output redirection operators that allows the user to multiple or to associate standard input-output with the disk file. That is, using the standard input-output function with the disk files. For example, typing Unix ls foo.txt that causes the shell that makes a shell to load and executes the ls program. This is used for loading and executing the ls program with the standard output redirected to the disk file foo.txt. That is, this is the redirection operator. One is ls, that is used for listing, that causes or that makes the shell to load and execute the ls program, that is list the values with the standard output redirected to the file, that is foo.txt. So foo.txt is a file name and ls is used for listing the program. A web server performs a similar kinds of redirection when it runs a CGI program, that is Common Gateway Interface, that is a CGI programs on behalf of the clients. So how does input-output reduction works? One way is to use the dub2 function, that is the duplicate to function. This is the example, that is a kernel data structure after redirecting the standard output by calling the dub2, that is a duplicate to for one function. The initial situation is the same, figure 11. That is the main condition where there is no sharing of the file. This is the example. First of all, this is the example. There is a duplicate function that duplicates the old FD to the new FD. That is making the old FD as the new FD. This says the dup2 function copies the descriptor table entry, that is old FD, to the descriptor table entry, that is new FD. That is copies all the table entries, all the data from the old FD to the new FD, overwriting the previous contents of the descriptor table entry new FD. If the new FD was already open, the dup2 closes the new FD before it copies the old FD. That is, simple terms, it copies the data from the old file descriptor to the new file descriptor. And if it is already open, then it first of all closes the old new FD, then again reopen the new FD. Suppose that before calling the dup2 for 1, we have the situation in figure 11, where descriptor 1, that is the FD1, corresponds to file A, and the FD4 corresponds to file B. The reference counts for A and B are equal. Figure 14 shows the situations after calling the dup4 1, that is duplicating the values of file descriptor 4 and the 1. 4 descriptor now points to file A. Why? Because there is a duplicacy. There is a duplicacy of the old file. Now there is a old file. What is the old file? That is a FD4. And what is the new file? That is a FD1. So all the contents of the FD4, that is representing the file B, is automatically converted into the FD1. That is the now FD1 is converted into the FD4. So FD4 is representing the file B. So if there is a duplicate value, so now file FD1 is also representing the file B. So this is how dup2 is used, that is duplicate 2 is used. Now both the descriptor now points to file B. File A has been closed and its file table and the vnode entries are deleted, and the reference count of file B has been incremented. From this on, any data returned to standard output is redirected to file B. So this is how we can use the input-output redirection. Redirection means how we can we are able to copy the data, or how we are able to duplicate the value of one file to the another file. That is how to create the duplicates value of files. That is using the Div function, that is a duplicate function. This is the example. Now fd1 fd4 using the div2 for 1, that is converting the fd4 into the fd2, that is fd1 becomes the fd4. Now both the file descriptor points to the file b, and this is the file that is deleted by the kernel. This is the main file. This is a dotted line shows that this is not the file that is in use. Now file b is accessing the file success, file size and file type. This is the input output redirection. Now let's see with the help of PPTs. The question is that how does a shell implement the input output redirection? This is the answer. By calling the div2 function, that is the old file descriptor, and the new file descriptor function that copies the file descriptor entries old fd to the new entry, that is the new fd. That is, it copies the file descriptor entries from the old file descriptor to the new file descriptor, that is the new fd. This is the file descriptor before div2, that is fda contains a and fd4 contains b. Now if it is a duplicate value, using the duplicate function, that is the 4 and the 1, now 1 is replaced by the 4, that is 1 is replaced by the 4. 1 contains a, b contains 4. Now 1 contains also the b and the 4 contains also the b. Why? Because 1 is overwritten by the or replaced by the fd4. This is the same example. Before calling the function, it points to a terminal and so on. It points to a disk file, the same fd1, fd4. After calling the function, now fd1 as well as the fd4 correspond to the only the same file, that is file b. Now next topic is standard input output function. That is, what are the standard input output functions that is available in the any programming language or in any programming functions. But before this, let's take a 5 to 10 minutes break and then come back starting with the same chapter, same topic, that is the standard input output. So let's take a 5 to 10 minutes break. Now let's start with the next topic, that is standard input output. So come back from the break and starting with the next topic. This is the 8th topic of this chapter. You see, these are the very easy topics and the short topics. We have started yesterday on the new chapter, and now we will reach, and we have reached till 8th topic, that is a standard input output. This is very easy and interesting as well as the short topics. Now, what is standard input output? As the name advises, standard input output means what are the standard inputs that is available and what are the standard outputs that is available. That is, in C language there are a different input that is standard. That is, standard means that is common to everyone. In the same way, in C++ there are different standard inputs and standard outputs. This says ANSI C, that is ANSI, that is American National Standard Code. That is the ANSI C, that is C language, defines a set of higher level input and output functions. That is, it defines a set of a group of higher level input output functions that is known as the standard input output library. That is, these or the ANSI provides a set of higher level input output function that is known as the standard input output library that provides the programmer, means that provides the facility to the programmers with a high level alternative to the Unix input output. That means they provide additional benefit, they provide the high level alternative to the input or to the Unix input output. That is, these standard functions provides the benefit to the Unix operating system or to the Unix input output. The library C, that is a library, provides the functions for opening and closing the files. That is the fopen function and the fclose function. In the same way, sorry, for reading and writing, the functions are or the library functions are the fread and the fwrite, and for writing and reading the strings there is a fputs and the fgets, and for sophisticated formatting we use the printf and the scanf. So these are the standard input output. There are separate input output functions for reading, for opening, for closing, for writing. So for opening and closing there is a fopen and the fclose. For reading and writing there is a fread and the fwrite. And for reading and writing the strings there is a fgets and the fputs. In the same way there is a scanf function and the printf function. This says the standard input output library models an open file as a stream. That is, this treated, or the input output, standard input output treats the open file as a stream. To the programmer, a stream is a pointer to a structure of type file. That is, stream is a pointer variable, or it is a pointer to the structure of the type file. Every ANSI C program begins with 3 open streams. Means every C program or any C program begins with the 3 open streams. One is standard input, that is stdin. One is standard output, that is std out, and one is standard error, that is std error, which correspond to the input, standard input, standard output, and standard error respectively. This is a function. One is used for standard input, that is the extern file standard input, extern file standard output, std error. A stream of file of type file is an abstraction for a file descriptor and a stream buffer. This says file is a function, or file is an abstraction for the file descriptor and the file buffer. The purpose of the stream buffer is the same as the RIO read buffer, that is to minimize the number of expensive input-output system calls. Suppose in a program that makes a repeated call to the standard input-output getC function, where each innovative returns the next character from a file. When getC is every time called the first time, that is when the getC is called the first time, the library fills the stream buffer with single call to the read function and then returns the first byte in the buffer to the application. So as long as there are unread bytes in the buffer, subsequent calls to the getC can be served directly from the stream buffer. So this says whenever there is a getC function, there is an unread buffer, then automatically it will be converted, or getC function is using for converting the unread buffer into the read buffers. Now, so in simple terms, this topic includes what is the standard input output, that is for reading, for opening, closing, fopen, fclose, reading, writing, fread, fwrite, reading, writing the strings, fgets, fputs, and the scanf and the printf. So there are basically 6 functions are used. One is fopen, fclose, fread, fwrite, 1, 2, 3, 4, 5, 6, 7, 8, not 6, 8, fgets, fputs, scanf, printf. So these are the 8 standard input output functions that is using, or that is used under the standard input output library. Now let's see with the PPTs. This says the library C, that is the C standard library, contains a collection of high level standard input output functions. That is this provides or it contains a collection of high level standard input output functions. That is the library C. Examples include same, the opening and the closing, that is fopen, fclose, reading and writing the bytes, that is fread and the fwrite, reading and writing the text lines, that is the fgets and the fputs, formatting, that is the fscanf and the fprintf, or simply scanf and printf are also used. Now, what is the standard input output stream? This says the standard input output models the open file as a stream. that any open file is treated as a stream. So if I am saying stream, that is an open file, that is a standard input output models open file, that is known as the stream. Abstraction for a file descriptor and a buffer in the memory. Any stream is an abstraction, that is a background content for a file descriptor as well as the buffer for the memory. C programs begins life with three open streams, that is it begins with three open streams that is defined in the header file, that is the which header file, that is stdio.h. What are the three open streams that is available? One is standard input, that is stdin. One is standard output, that is std out. One is standard error, that is std error. So these are the three inputs that is available, that is standard input, standard output and standard error. And this is the example of using the standard three open streams. One is how it will be used by using the header file, that is the stdio, that is standard input output.h, using the extern keyword, using the file pointer, that is a file, using the pointer, that is a pointer stdin. In the same way, extern file pointer std out. One is the standard input, that is a descriptor 0, standard output, that is a descriptor 1, standard error, that is a descriptor 2. Using the int main function for printf, first of all means writing the file, that is a standard output, writing the hello world in the next line. So this is the concept how it will be used. Then buffering in the standard input output. This means standard input output function uses the buffered input output, that is it uses the buffer, that is uses the memory for one concept, that is H is writing separately, that is E is writing separately, LLO writing separately, that is using the printf function. Then this is the buffer, this is the memory, there is a f flush, that is using the flush function for using the standard output. Then use the write function, that is buff plus equals to 6 at the 6, that is 1 2 3 4 5 6. At the 6th location there is a finish, that's why it is using the buff plus equals to 6. This is how buffering is done in the standard input output. Next, standard input output buffering in the action, that is how standard input output buffering is done is in the action. This is, you can see this buffering in action for yourself using the always fascinating Unix trace program, that is using the trace program trace program for the standard input output buffering, that will be in the action. First of all, there is a header file, that is hash include standard input output dot h. There is a main function, that is a int main. Then there is a int main, then there is a printf. First of all, hello will be used, then print, first of all the h character will be printed, then e character will be printed, then l, l, o, then there is a gap of the line, that is h, e, l, l, o, then there is a gap. Then using the flush function for the removing the or for storing the values in the output, that is a std output. Then at last exit 0, that is why we are using the exit 0, because we are using the int main. This is the example by using the trace function or strace function. This is a Linux command, that is strace hello, that is how it will be used by using the strace hello. Then using the function, that is execute ve hello hello, write 1 hello and 6, that is till it is reaching to the 6, that is at the end of the line, at the end of the character, at the end of the place it will be placed, and then at last exit 0. Next, Unix input output versus standard input output versus RIO. Means what is the difference or what is the comparison between the Unix input output, standard input output and the RIO. So what is the main difference between all the three values, that is the standard input output or Unix input output and the RIO. First point says standard input output and RIO are implemented using low level Unix input output. That is these two, one is standard, one is RIO, are implemented using the low level Unix input output file. So how it will be used? Now let's see. This is the fopen, fread, fscanf, scanf, fgets, fflush, fclose, fdopen, fwrite, fprintf, fprintf, fputs, fseek. So these are the standard input output functions. As I told you, these are the standard functions that are implemented using the Unix input output functions, and these are the Unix input output functions that are accessed via the system code. That is the open, write, stat, read, lseek, close. Then there is a separate RIO function, that is a readn, writen, read init b, line b, and b. This is used for reading, writing, for initialization, that is starting, for the text lines, for the binary lines or the binary bytes. Then this is the Unix input output function that is common to the both, or that are used as an implementation for both standard input output and the RIO functions. Then there is a C application program. Means if I compare all the three one, so the two, that is the Unix output input output and the standard input output are the different, but the standard input output and the RIO are the same, and that are implementing using the Unix input output. Next point says, which one would you use in your program? This is the main question. Now what is the pros and the cons of the each one, that is Unix, standard, and the RIO? So what are the pros and cons of the standard? First of all, Unix input output. This says Unix input output is the most general and the lowest overhead form of input output. This is the advantage, that is the cost is very low in the Unix input output. All the packages are implemented using the input output functions. Then next pros or the next advantage is that Unix input output provides functions for accessing the file's metadata. That is, it is using the functions, or this Unix input output provides various functions for accessing, that for accessing the file metadata. That is, the data about the data can be accessed by using the Unix input output. Next, what are the limitations of Unix input output? That is, dealing with shortcut is very tricky and the error. That is, shortcut is one of the biggest limitation in the Unix input output. Next limitation is that efficient reading of text lines require some form of buffering, also tricky and the error prone. Next point, both of these issues are addressed by the standard input output and the RIO package. That is, the limitations can be removed by using the standard input output and the RIO package. Now what are the advantages and the disadvantages of standard input output? First of all, there is an advantage. The advantage of standard input output is that buffering increases. That is, if I'm using the buffering, that increases the efficiency by decreasing the number of read and the write system calls. That is, if there is a buffering, that decreasing the number of times we read and number of times we write the system calls. And short counts are handled automatically by using the standard input output. What are the cons? Means what are the limitations? That it provides no function for accessing the file metadata. That is, there is no standard input output functions for accessing the file metadata. It is next limitation is that it is not appropriate for input and output on the network socket. That is, it is not used, or it is not used with the standard, or it is not used with the socket that is used, or it is not used with the socket file. Next limitation is that there are poorly documented restrictions on the stream that interact badly with the restrictions on the socket. That is, there is some restrictions on the stream that is available, so there is poor documented or poor documentations on the sockets. Next is restrictions on the stream. Next limitation is restriction on the streams. That is, what are the restrictions? Input function cannot follow the output function without interleaving call to the flush, fseek, fset position, rewind. That is, there is a restriction on the given files. What are the restrictions? That input function cannot or cannot follow the output function. Next restriction is that output function cannot follow an input function without interleaving calls to the fseek, fgets or the rewind, set position function. So these are the limitations of the standard input that provides the restrictions on the string. Again, next limitation is that there is also a restriction on the sockets. That is, you are not allowed to change the file position of a socket. Automatically it will change, but you are not allowed to change the permission. Then how to work out for the restriction 1, that is flush stream after every output. This is the restriction 1. Then what is the provision, or what is the solution for restriction 2? Open the two streams on the same descriptor, one for reading and one for writing. That is, one is used for reading purpose and one is used for writing purpose. Now, next is you are putting it together, which input output function is used. Next is you are putting it together, that is, which input output function should I use. That is, what are the pros, what are the cons that we have discussed. Depending on that, which input output function we should I use. This says figure 15 summarizes the various input output package that we have discussed in this chapter. This is figure 15, that is the relationship between the Unix input output, standard input output and the RIO. The same, this is the Unix input output function that acts as an intermediate between the standard output and the RIO function. That is, this is the base for the standard input output and the RIO function. This is the C application program. This is the different standard input output functions. This is the Unix input output functions. This is the RIO functions. This says Unix input output is implemented in the operating system kernel. It is available in the, or it is available to the applications through the functions such as open, close, lseek. These are the functions. Open, close, fseek, flush. The higher level RIO and the standard are implemented on the top of the Unix operating system. This is the RIO functions are operated or implemented on the top of the RIO functions. This says the RIO functions are the robust wrappers for read and the write that were developed specifically for the textbook. The standard input output provides a more complete buffered alternative to the Unix input output functions, including the formatted input output routines. This is the same what we have studied with the help of the PPTs. So which of the functions would you use in your program? The standard input output functions are a method of choice for input output on the disk and the terminal. Most C programmers uses the standard input output throughout their careers, never bothering with the low level Unix input output functions. Whenever possible, we recommend you to do likewise. That is, mostly programmers, or most of the time, the standard input output functions are used. So that is the best way, and this book also recommends you to use the standard input output function for the program. Unfortunately, the standard input output poses some nesty problem when we attempt for the input output on the network. That is, it is not available for the network. That is the type of the file, that is socket. Then standard input output streams are full duplex in the sense that programs can perform input output on the same stream. That is, what are the restrictions that is available? Input functions following output functions. That is, input function is follows the output function, that is they are dependent on the output function. In the same way, restriction number 2 is that output function follow the input function, that is using the fseek, fset position or rewind. These are problems, and this problem can be solved by using the multiple way, by using the two streams. One is used for socket buffering, one is used for reading and the writing. This is the last paragraph. Thus we recommend that you should not use the standard input output for on the network socket. Use the robust RIO function instead. It means if I crux all the methods, then if there is a network socket, then use the RIO functions, otherwise use the standard input output functions. Means if you see that there is a networking or network socket, then you use the RIO, otherwise you use the standard input output functions. So that's all. Now there is a summary. That's what we have covered. Unix provides a small number of system level functions, blah blah blah. There is a open, close, read, write, file metadata, input redirection, Unix read and write operations. The standard input output is implemented on the top of Unix input output and provides a powerful set of high level input output routines. So this chapter is finished. You see, this is very small chapter. I've started yesterday and this is finished only today only. These are the various problems, solution to the practice problems. Only 5 problems are there in this chapter because this is very small chapter. Now, next chapter is your concurrent programming, that I will be starting in the next class, that is the tomorrow's class. This is also a small chapter, only 8 topics or 7 topics are there in this chapter. So that's all for today's session. Now if you have any doubts, then please text the doubt and I will answer you. Let's see. Next is the same, choosing the input output functions, when to use this one when working with the disk or the terminal files, when to use the raw input, Unix input output, when to fetch the file metadata. So this is the comparison, that is when to use the standard input output, when to use the Unix input output, when to use the RIO. For further information, that is, this is not your, no. So that's all. Thank you so much. If you have any questions, then please text the questions and I will answer you. So that's all from my side. Tomorrow I'm going to start with a new topic, that is the concurrent programming. So that's all. Thank you so much everyone. Bye bye.